Morning, people.
Morning, sir.
How are you?
We are fine. How are you, sir?
I'm fine. Okay. Today we are going to look at the algebraic equation. Né?
Yes.
So remember last time we did algebraic expression and algebraic equations, and under the algebraic equations we're specifically looking at the weight equation. So we're on the weight equation, we're able to analyze the weight equation and solve. Now, today we're not going to look at the weight equation, we're going to look at the equation itself. And on the equations, we know that there's a variables. For example, on equations, if we have 2x and 4 equals to 10. So this is a weight equation, is a normal equation where there is a variable. A variable, we know it represents an unknown value. Yes. And a variable is represented by a letter. And the number before the letter is a coefficient.
Yes.
So we can also write to say this one is a coefficient and this one is a variable. The reason why it's called variable is all because it can change the value at given time. Okay? Yes. And this one will be presented as a constant. Yes, is a constant. And this one is the result. That means, remember that the equal sign, it means that the left hand side is equivalent to the right hand side. So us, when we calculate today with the equation, we want to figure out the value that makes the equation to be true. We want a value that makes an equation to be true. Okay, yeah. I want to give you this one. Yes. What is that? Okay, now, I'll give you this one as an example. Yes. For example, if we have x subtract 8 equals to 34. I want us to look at this to find out the value that makes the equation to be true. I know this one said the x is the variable.
Yes.
It represents a certain number.
Yes.
So if it represents a certain number, it says that this side is equivalent to this side. As our duty is to think of a number that is multiplied by 3. When we subtract 8, we get 34. In order to make the equation to be true. What is the number that multiplies 3 and subtract 8 to get 34? Think of a number that is standing for the variable. Think of a number that is standing for the variable. When you multiply that number by 3 and subtract 8, we get 34. What is that number? You can use a trial and error method of thinking of a number. You can put 10. Let's put 10. 10 multiplied 3.
10.
Subtract 8. We get 20. We get 22.
Yes.
So that means 10 is not the number that makes the equation to be true.
Yes.
So let's try. Let's try 11. 11. 33 subtract 8. 25. That means the 11 is not the number.
Yes.
So, but immediately when you use the number, we can see that you are going there, you are approaching 34 again.
Yes.
So, what is the number that we can put here on the variable that can make the equation to be true? Let's try 14. Yes, let's try 14. 14 multiplied 3 is 14, 28. 14 plus 28 is what? 14 plus 28. 42 then?
Yes.
42 subtract 8. 34, yes?
Yes.
So that means the x here is representing 34 and 14. Because 14 is the one that when you place x, it makes the equation to be true. So, but that method that we just used is a trial error method of guessing. So now, today we don't want to guess. We want to solve properly in order for us to find the number that makes the equation to be true. And remember, so when we solve this, okay, we said here with the trial error x is equals to 14. And we say number one, the two sides of an equation will remain balanced if you do the following. Number one, you add or subtract the same value, the same number from both sides. That is what we should keep in mind to say when you add or subtract the same number both sides, the equation remains balanced. That means it does not change, because it's only balanced by the equal sign. Because equal sign represents that both sides are equal. And the other thing, multiply or divide both sides by the same number. When you multiply the same number, when you multiply or divide by the same number, the equation remains balanced. Yes. And as we are going to use those two methods of subtracting, adding same number in both sides in order for us to balance the equation. And that we refer to it as the additive inverse. We are going to use the additive inverse. This one is called additive inverse, and this one is the multiplicative inverse. So now I'm going to show you this one that we started with. To say, as an example, 3x subtract 8 equals to 24. And remember, the first step says that add or subtract the same number from both sides, and the equation remains balanced. Yes. So when we add, remember we're looking for the value of x. Let's say here the question says solve for x, and we solve for x by using the additive inverse. Yes. So now additive inverse, we are looking at we want to remove 8. And we must find the additive inverse of 8. Remember, inverse means opposite again. Yes. What is the opposite of negative 8? It's positive 8. We add both sides. We are going to say 3x subtract 8, add 8. And we're also going to do the same this side. Plus 8. We added 8 both sides because it's the additive inverse of negative 8. Yes. Negative 8 plus 8, negative 8 is 0. So we get 3x equals to 34 and 8, 42. 42. And now we must get rid of 3. And we said that we can use additive inverse or multiplicative inverse. Yes. So we already use the additive inverse. That means we must go to the multiplicative inverse. We must find the multiplicative inverse of 3. So we can say that if it's 3, the multiplicative of 3 is 1 over 3. So 1 over 3 is an inverse of 3. Because when you multiply them, you get 1. Yes. So therefore, we say we multiply both sides by 1 over 3. 1 over 3 multiplied by 3x equals to 42 multiplied by 1 over 3. So therefore, we say numerators multiply numerators. Denominators multiply denominators. And now after that, we simplify. 1 multiply 3.
3.
3 divided by 3?
1.
1. Then we're left with x.
Yes.
42 multiply 1.
42.
Divide by 3.
14.
We get
14.
So we can see this method.
14.
It's 14. Why I wrote 4, man? It's 14.
Yes.
So we can see this method is not the same as this one, where you use a trial error in order to find the answer.
Yes.
But you use the processes that is going to make it easier. Because now this one is supposed to guess, continue to guess until you find the number. But this one, we use the additive inverse and the multiplicative inverse in order to find the value of x. So now, if we can check 4, or let's check, then we say check your answer. So let's check our answer. That means when we see x, we are going to replace it by 14. And we must get a different value for both sides.
Yes.
So therefore, it's 3 multiplied by 14, subtract 8 equals to. So this one is 42. Subtract 8 is 34 and 34. So you can see that the equal sign indicates to say both sides are equal. So now I want to give you another one. Okay, I want to give you this one. That's number B there.
Yes.
It's number B. I want to give you this one. Number B. Remember to solve for x, right?
Yes.
So we say is x all divided by 3 equals to 10. I want you to try this one as an multiplicative inverse. I'm going to give you 1 minute for you to try this. Then. Or maybe we should do it together.
Yes.
Okay. We take this one, x divided by 3, s 1 over 3 multiplied by x equals to 10. It's the same, eh? So now we must get rid of 1 over 3. If here the multiplicative inverse of 3 it was 1 over 3, what is the multiplicative of 1 over 3? 3 is the multiplicative inverse of 1 over 3. That means both sides will multiply by 3. So we're going to say 3 multiplied by 1 over 3 multiplied x equals to 10 multiplied by 3. So therefore we're going to say this is the same as over 1. Eh?
Yes.
3 multiplied 1.
It's 3.
1 multiplied 3.
3.
That is x. 10 multiplied 3 is 8. So 3 divided by 3.
1.
That is 1 and we have x is equals to 8. Can you see how easy it is?
Yes.
Okay, let me give you another one. Number C, where you are going to put on your own.
Yes.
3x subtract 5 equals to x at 9. Okay. Now, let's look at this again. What is the value of x? Have you found it there when you calculate? What is the value of x, Precious? Okay, let's do it. Let's do it together. And this one is not the same as the one that we started with because now it has 2x both sides again. So that means when you think of a value that can make the equation to be true, you must think of a value that can put it here and make this two sides to be equal again. So then now, using the guessing method, we're just going to keep on trying the different numbers again in order to see whether it makes this side, both sides to be equal. But because we can add or subtract the same number and multiply or divide the same number both sides because we know that it gives us, it balances the equations. So now we can start with 5. And it's negative 5. What is the inverse of negative 5? It's positive 5. Go to 3x, subtract 5, add 5. Also do the same this side. We add 5, and whatever 3x equals to x, add 9, add 5. Okay. 9. 14, yeah? Yes. So, but we must also get rid of x so that it can come this side, yeah? Because we must group the like terms in one side. The one that have x must be on one side, the one that are numbers on the other side, in order to get the value of x. So now, if x is here, we must also find the inverse of x. If it's positive x, that means the inverse of x is going to be what? Negative x, no? Yes. And we're going to subtract negative x both sides because it balances the equation. It balances the equation, no? So it's going to be 3x subtract x. X subtract x and 14. 3x subtract x. If we have 3 orange and take one out, how many orange will left with? Okay, if we have 3x and take one out, how many x will left with? So then we're left with 2x here. And 2x, then this side, x subtract x, we don't have x anymore. Right? 14. And what is the going to do when we have 2x? We are looking for the multiplicative inverse of 2. Yeah, we want multiplicative inverse of 2. If we have 2, what would be the multiplicative inverse of 2? 7. I think we said 1. What was the multiplicative inverse of 3? 1 over 3. Yes. What was the multiplicative inverse of 1 over 3? What is the multiplicative inverse of 2? 1 over 2. 1 over 2 multiplied 2 equals to 14 multiplied by 1 over 2. 1 multiplied 2? 2. And 2 divided by 2? 1. And this is going to be x. 14 multiplied by 1? 14. Divided by 2? 7. Now let's check our answer. Whether it's correct or not. By checking now. Or whether it's going to equate both sides. So now let's check. That means when we see x, we put 7. So I'm going to say 3, 7, subtract 5, 7, 8, 9. 3 multiplied 7 is 3, 4, 21. 21 subtract 5. make the two sides to be equal and you make the equation to be true.
Yes.
How does it make it to be true? The two sides are equal. So let me give you another one. And here, we're still solving for x. We're still solving for x. Now, we will be done. This one, for what you put the two last ones, and we're done.
Yes.
So, what is in this one? X subtract 4 equals 3. Find the value of x that makes the equation to be true. Find the value of x. The first thing that we do, we group by subtracting or adding the additive inverse.
Yes.
What is the additive inverse of 4? Positive 4.
Yes.
We add 4 both sides.
Yes.
So therefore x equals
7.
7. Okay, let's put 7. If the x is 7, 7 subtract 4, we get 3.
Yes.
So this one is the last one for the day. And after that we're done. 2y equals to 22. 2y equals to 22. So now let's find out. So what is it that what is the first step that we're going to apply here? Yes, what is the first step? The multiplicative inverse again.
Yes.
What is the multiplicative inverse of 2?
It's 1 over 2 multiplied by
Okay.
2y.
1 over 2 multiply
2y.
2y again. We do both sides again.
2 multiplied.
So 1 multiply 2
It's 2.
is 2. 2 divided by 2 is 1. Then we're left with y again.
Yes.
22 multiply 1
22.
divided by 2.
11.
11. Yes. And we're done for today.
Yes.
Anyone with a question? Yes.
Say the exponents and the algebraic equation.
Yeah, we have exponents. The next one we're going to do how to solve with the exponent. Yes. Tomorrow you're coming.
Yes.
Yeah, if tomorrow we're coming. Tomorrow we're going to do the one over algebraic equation using the inverse. The exponent.
Yes.
Okay, thank you very much for that. We'll wait tomorrow.